SI units and measurements. The SI system has a base unit or standard unit for every type of measurement. SI stands for Sistema Internazionale. Oh, I said that like I was Italian, but it's French. Oh, whatever. Which is French for international system. How chic. So if we're measuring length or distance, we're going to use meter. Mass is gram. Weight or force is Newton. Volume or capacity is liter. Temperature is Kelvin. Time, second. Electric current is an ampere. Amount of substrate is a mole. And light intensity is a candela. Because we want to use SI units to describe both the distance around someone's bicep and the distance around Earth, we need to be able to change the size of a unit to fit the measurement. Scientists devised a system of prefixes that multiplies the base unit by factors of 10. Just by switching the prefix on an SI unit can be used for measurements big and small. Giga, we multiply by, what is that? 1 billion. 1 billion. Mega, we multiply by 1,000,000. Kilo, we multiply by 1,000. Hecto is 100. Deca is 10. The base unit is 1, meaning that if it's a meter, it's just a meter. We don't have to multiply it by anything. Deci, we multiply by 1/10. Centi by 100th. Milli by 1,000th. Micro by 1,000,000th. And nano by a billionth, I think that is. 95% of the world uses SI units as their everyday system of measurement. So our mnemonic for SI prefixes is Great Mighty King Henry died by drinking chunky milk Monday night. Ugh, that's gross. SI unit conversions. Because the SI prefix system is based on powers of 10, it's really easy to convert between units. If you're converting to a smaller unit of measurement, simply move the decimal point to the right as many places as the difference in place value. If you are converting to a larger unit of measurement, move the decimal point to the left as many places as the difference in place value. For example, if we have kilometers and we're changing it to a meter, we're going to move our decimal point over 1, 2, 3, and we get 100 centimeters. Remember, common sense tip, remember to use the best fitting unit. If you measured the volume of the ocean with the same units you use to measure a glass of milk, the numbers would be very difficult to work with. The volume of the ocean should be measured using much larger units. Types of measurement. Length is the distance between 2 points. Volume, the amount of space something occupies. Mass, the amount of matter in a liquid, solid, or gas. And weight, the force exerted by a mass. When you measure someone's weight, you measure the force they exert on the earth. Mass and weight are not the same. Mass is the amount of matter in an object, and weight is the force applied by a mass. Weight relies on gravity, a force, but mass doesn't. For example, the moon has less gravity than the Earth, so objects weigh less there than on Earth, but mass always remains the same. Weight changes. Density, the amount of matter in volume. Temperature, how hot or cold something is. While the SI unit for temperature is Kelvin, most scientists use the SI derived unit, Celsius, to measure temperature. If you do use Kelvin, Kelvin doesn't use a degree symbol. Sink or float. Something denser will sink below something that is less dense. When oil is poured into liquid water, it floats on top of the surface because oil is less dense than water. A stone sinks in water, so it's denser than water. Water has a density of approximately 1, so oil's density must be less than 1, and a rock's density must be greater than 1. This is the formula to convert Celsius and Kelvin. The temperature in Kelvin equals the temperature in Celsius plus 273 and 5/10, or the temperature in Celsius equals the temperature in Kelvin minus 273 and 5/10. In the US, we usually use Fahrenheit to measure temperature. This is the formula to convert Fahrenheit and Celsius. Temperature in Fahrenheit equals the temperature in Celsius times 9/5 plus 32, or temperature in Celsius equals temperature in Fahrenheit minus 32 times 5/9. Notice here the boiling point of water. It boils at the same temperature technically, but because we use different measurements, it's going to look different. So Fahrenheit at 212 degrees Fahrenheit is the same as 100 degrees Celsius, is the same as 373.15 Kelvin. And that's the temperature that water boils at. So in Fahrenheit, human body is 98.6. In Celsius, it's 37, and in Kelvin, it's 310 and 1500ths. A warm day temperature, 77 degrees Fahrenheit, is 25 degrees Celsius and 298 and 1500ths Kelvin. Freezing point of water, 32 degrees Fahrenheit, 0 degrees Celsius, and 273 and 1500ths Kelvin. Now, absolute zero is where molecules stop moving completely. We couldn't exist. So in Fahrenheit, that's at negative 459 degrees and 67 hundredths. In Celsius, that's at negative 273 degrees and 1500ths. And at Kelvin, it's at 0. Time is the period between events, or how long something lasted. The SI unit for time is seconds. Other units for time include hours, days, months, and years. Measurement tools. Distance. Meter stick. Like a ruler, except it's 1 meter long, 100 centimeters. It's a bit longer than a yardstick. Trundle wheel. To measure long distances, just roll the trundle wheel on the ground, and every time you walk a meter, the trundle wheel will make a clicking sound. Simple, just remember to count the clicks. Tape measure. For measuring distances that would be hard to measure using a meter stick or a trundle wheel, such as the distance around a round object. Volume, graduated cylinder. A cylinder marked on the outside to indicate how much fluid it contains. Take your volume reading from the bottom of the meniscus and make sure you are taking the reading at eye level. Meniscus is the curved surface of a liquid in a tube. So the meniscus is here. It's curved right here, right? So we take it from the lowest bottom of the meniscus. Volume of solids. To figure out the volume of a rectangular solid, simply measure its height, width, and length using any of the tools for measuring distance, and then multiply all three. Volume equals length times width times height. For other geometric shapes, you'll have to look at your math notebook. Volume of irregular solids. The best way to measure the volume of an irregular solid is to place it in water and find the volume of the water it displaces. The difference between the new and old volume measurements is equal to the volume of the object. Next time you get in a bath, look at the water you displace. That's your volume. So see if the water's here, when we put the rock in and it goes up, the difference between the volume up here and the volume here is the volume of this object. Mass, electronic balance. Just put the object on a pan and read the mass. Double pan balance. This compares the weight of objects in pans on each side of a balance. To find mass, place something of known mass in one pan, and the other pan, place the object of unknown mass. When the pans are level, the masses are equal. If you're measuring something that needs to be in a container, weigh the empty container on its own first, and then subtract the weight of the container afterwards. Triple beam balance works like a double pan balance, but instead of having a pan on each side of the balance, there is a pan on one side and 3 beams, each with sliding weights called riders on the other. Density. Because density is simply the amount of matter in a certain volume, you can calculate density by measuring the volume and mass of an object and dividing like so. Density equals mass divided by volume. Time. To measure time, you can use a clock or a stopwatch. If you are using a regular clock, subtract the start time from the end time to figure out how much time has elapsed. Temperature. Thermometer. Used to measure temperature. A thermometer can be digital or it can be a liquid thermometer, which contains a liquid that changes volume with temperature. When taking temperature, make sure the bulb at the end of the thermometer is in the middle of the liquid you're measuring and not touching the sides or bottom of the container.